Hi everyone, it's Mrs. Bebo. In this video, we're going to take a look at using the distributive property to simplify algebraic expressions. The distributive property states that to multiply a sum or difference by a number, we're going to multiply each term inside the parentheses by the number that's on the outside of those parentheses. So you can see that we have it written out in symbols here on the left-hand side of this table. So if we have A that's being multiplied by the quantity of B plus C, essentially we just do A times B, carry your plus sign over, right? So that plus sign's still in the middle, and then we do A times C, and then we have that term over there. And essentially, we've simplified the expression by removing those parentheses. If you can recall back from the first video in this series, one of the things that we talked about was what does it mean to simplify an expression? And it means to combine all like terms and to remove any parentheses. And the distributive property is what helps us to be able to do that. It also works again for subtraction. So we have a difference of B minus C inside the parentheses here on this bottom example on the left. So we're going to do A times B, which is AB. We can do A times C, which is AC, and then we have our subtraction sign in between. And then if we can go further with it, great. Otherwise, that's where we end. So we're going to see a lot of examples like that in this video. So using the distributive property to expand these expressions, expand also another way to phrase that is to simplify, because these are not simplified expressions when you have that factor being multiplied by this quantity, again, either a sum or a difference inside those parentheses. So for this first one, we got 4 multiplied by the quantity of negative 3x plus 6. So when you have something like this, again, it's not simplified. So to simplify it, we use the distributive property. And one of the things that I advise to my students is to draw these arrows to help us remember, hey, we're taking 4, multiplying it by negative 3x. And while you're first starting to learn it, you might want to write out those in-between steps too, just to make sure you're not forgetting those. And then we have an addition sign, and then I would draw another set of arrows to show that I'm doing 4 times 6. So we're going to do 4 multiplied by 6. And then we just multiply this out. So to multiply this out, we're going to do 4 times negative 3x, which is negative 12x, plus we have 4 times 6, which is 24, and then that's it. That's as far as we can go with it. These are not like terms, so this would be my final expression. So now we're going to do the same thing on this next example. We have 7 multiplied by the quantity of negative 2x plus 3y. So to get rid of those parentheses, we're going to multiply whatever's on the outside to everything that's on the inside. So starting off with the negative 2x term. So again, we can show our steps here. We're going to do 7 multiplied by the negative 2x. We have an addition sign in between, so I'm going to carry that down. And then we're going to do 7 times the 3y. So now 7 times a negative 2x, that's going to be a negative 14x. Bring down my plus sign. And then 7 times 3y is going to be a 21y. And that's as far as we can go. Again, those are not like terms, so this is my simplified algebraic expression. All right, the ones on the bottom here do look a little bit different. They're the same exact things as what we just did. So sometimes students get thrown off when that factor's on the end of the linear expression or algebraic expression in this case. And it's just the same thing. It's that quantity that's being multiplied by a 3, or in that bottom one on the right, again, that quantity is being multiplied by 4. They just wrote the multiplication after the parentheses rather than out in front. If you need to, you could always rewrite it so that the 3 is in the front and then just ignore the one on the back, right? Because you just move it to the front. Or again, just know that it's the same thing we've been doing. So we can start out by writing 3 times the 2x. And again, I would still draw those arrows. They're just coming from the back side now, right? Now we have a subtraction sign in between, so I'll carry that subtraction sign down. And then we're going to do 3 times 5y. And then multiplying this out, 3 times 2x is going to be 6x. Subtract 3 times 5y, that's going to be 15y, and that's as far as we can go with that question. So finishing up the last example on here, again, we're going to expand or simplify again this algebraic expression. We got 4 times a negative 3x, so again, I'll write out my steps here. Then we have our subtraction sign, and then we have 4 times 8. And then multiplying this out, 4 times negative 3x would be a negative 12x. Subtract 4 times 8, which is 32. And that's it for those examples. So again, we just multiply. It's a lot of multiplying. Just make sure you're multiplying to everything inside those parentheses. And again, drawing those arrows can be really helpful to make us visually see, okay, did I actually take the 4 and multiply it to negative 3x, or I take the 4 and multiply by the 6? So that would be my advice when you guys work on these distributive property questions. Use those arrows to help make sure you're multiplying to everything that's inside those parentheses. All right, so sometimes with a distributive property, we also see examples that involve our geometric figures. So these ones say to write a simplified expression that represents the area of each figure. So hopefully we remember that the area formula for a rectangle, which is what we have in both of these cases, is the area is equal to the length multiplied the width. Some students also like to say base times height. It's essentially the same thing. Technically, the formula is length times width, but essentially you're taking your 2 side lengths and multiplying them together. So what we have here is we have basically these rectangles that are made up of 2 separate ones, right, that are coming together to form a larger rectangle. And so the idea behind this is that we have our length here, right? And then we also have a width over on this side. So we basically need to come up with the expression to represent that entire side length. So if we have 3x and this 2 all together, this is 3x plus 2. That's really all it is. And then now to write this simplified expression that represents the area, well, we just said area is equal to the length times the width, right? So we're going to be doing 5 multiplied by the 3x plus 2. Now we can't leave our answer as 5 multiplied by the quantity of 3x plus 2 because again, that's not simplified. There's parentheses involved there. So we're going to multiply this out by doing 5 times 3x and 5 times 2. So 5 times 3x will be 15x. Bring down my plus sign. 5 times 2 is 10. And then that is the expression for the area of that figure on the left. And we know that's going to be that as well if we go through and kind of look at each portion of this larger rectangle, right? If we look at each individual portion here, the 5 times 3x, right, for this portion right here, 5 times 3x is 15x, which is what we had for the first part of that expression there. This piece here on the end, 5 times 2, that's 10. And so you can see we have a 10 here. And again, together, the 15x and the 10 represent the area of the entire figure. We just use the distributive property to help us come up with that. And so the same idea is going to apply on the second one here. So again, we can write an expression to represent the entire area, first just as an unsimplified expression. So we have the fact that this side length here is 7, and then this side length here, again, is the x and 9 together. So this is going to be represented by x plus 9. So my area is going to equal 7 multiplied by the quantity of x plus 9. We're going to use the distributive property to simplify this because, again, it's not simplified when there's parentheses. So 7 times x is going to be 7x. Bring down my plus sign. 7 times 9 is 63. And there is my simplified expression for that one. All right, so more geometry applications with distributive property. Now this one says the side lengths of 2 triangles are shown. We're going to represent the perimeter of each triangle with an expression in simplest form, and then we're going to determine which triangle has a greater perimeter if x is equal to 3. So there's 2 parts to this. First, we're going to represent the perimeter of each triangle with an expression in simplest form, because that's going to be helpful for when we have to determine the second part of this question. It's a lot easier and quicker to calculate that out once you have the perimeter in simplest form. Now to find the perimeter of a shape, we add up its outside lengths. So for triangle 1, we're going to be doing 10 plus 4x plus, we have this final one, which is 3 multiplied by the 4x minus 5 inside parentheses. So this is actually going to be bringing in stuff that we talked about in the last video with combining like terms, but our first step is to use the distributive property, which again is the main focus of this video. We're going to be doing 3 times the 4x and then 3 times that 5. So I'm going to have this 10 plus 4x still out front, but now we're going to have plus 3 times 4x, which is 12x, bring down my subtraction sign, 3 times 5 is 15. So this is now where, again, that last video's concept of combining like terms is going to come into play, because we do have like terms in this case. I would advise rewriting that subtracting 15 as adding a negative 15. So that way we know when we're combining this 10 and this negative 15, that that's going to end up being, again, a positive plus a negative value. We also have our 4x and 12x. Those two are like terms, so those are going to be combined as well. So starting with the variable terms, we got 4x plus 12x. That's going to be a total of 16x. We have 10 plus negative 15. So different signs means you're going to subtract. So we're going to get 5, and then it's going to be a negative because we have more negatives to in that problem, right, with the negative 15. So I'm going to write this as plus negative 5, and then we'll just clean that up again by writing it as minus 5. So also mentioned in the last video, it's better to rewrite your final solution with a subtraction sign rather than leaving it as plus negative, because that's technically not simplified. So rewriting it as just minus is the way to go. So that's the simplified expression for the perimeter of triangle 1. Now we're going to do the same thing for triangle 2. So for triangle 2, we have 11, and then we have adding to that the 3, and then in parentheses negative 2x plus 9 plus 5x. So again, all I did was just write all of the edge lengths added together. And now we have to go through and simplify. So we're going to distribute first. So anytime you have parentheses involved, you're going to do that first. So multiply, multiply. The 11 still hanging out front, so we got 11 plus the 3 times negative 2x will be a negative 6x, plus the 3 times 9 is going to be 27, and then we have that 5x on the end. Okay, so we use the distributive property first to get rid of that quantity, and now we have 4 individual terms. Combining those like terms that we have in this case, so similar to last time, we have these constants here that can be combined, and then we also have our variable terms, which can be combined as well. So this negative 6x and the 5x. So starting with the variable terms, negative 6x plus 5x is going to be negative 1x, or just negative x. And then 11 plus 27, so our constants, 11 plus 27 is going to make 38. And so that is my simplified expression for the perimeter of triangle 2. So the first part is done. Representing the perimeter of each triangle with an expression in simplest form, check. Now we're going to determine which triangle has a greater perimeter if x is equal to 3. So now what's really nice is that when we have these simplified expressions, you're only having to plug in that x into one spot rather than 2 separate places, or even more, right, depending on what the problem was. So it's really nice when you have, you go from an expression that's pretty long to something that now just requires essentially 2 steps to solve, or 1 step. So for the one on the right, if we start with this one, because this one's actually going to be a little bit quicker, we're going to have negative x, so negative 3, because we're letting x be 3 based on the question, plus the 38. That means now my perimeter is 35 units. Versus what we're going to get for triangle 1, which again, super nice. We're just going to be doing 16 times 3 and then subtracting 5. So 16 times 3 is going to be 48. So we're going to have 48 minus 5. And then 48 minus 5 is going to be 43. So we got 43 units versus the 35 units. So the triangle that's going to have a greater perimeter, we're going to find that triangle 1 has the greater perimeter when x is equal to 3. And again, super quick calculation once we've had that simplified expression, which is why in math we tend to say, hey, simplify, because it does make your calculations a lot quicker when we have, again, those simplified algebraic expressions to work with. All right, so now we're going to do essentially a speed round with some distributive property questions. So lots of examples on this slide. So we'll start with, again, number 6 that's in the top left corner of this table here. So 5 times 6x, and then we're going to do 5 times 9. So 5 times 6x, again, you can actually multiply 5 times 6 to get 30. Make sure you have your x next to it. Bring down your plus sign. 5 times 9, 45. Again, these are not like terms, so be careful not to go too far with the question. Go as far as you can with combining like terms. If there are none, like in this case, that's your answer. You just needed to make sure you got rid of those parentheses. So number 7, same idea. 4 times 3k, 4 times 2. 4 times 3k is going to be 12k. Bring down my subtraction sign. 4 times 2 is 8. And there you go. That's your answer. Number 8, we're going to have 1.5 times 6t, and then 1.5 times 2. Again, that 1.5, remember, you can think of this as 15. So we can think of that as 15 times 6, and then add in 1 decimal place when you get done multiplying that out. So 15 times 6, if you were to do your long multiplication there, you get 90. but because it was 1.5, technically, this is actually going to be 9.0, or just 9. So that first distribution, the 1.5 times 6t, is going to be 9t. Then we bring down our plus sign, and then 1.5 times 2, again, the same idea. You could think of it as 15 times 2, which is 30, but then adding in that 1 decimal point, so that 1 decimal place, you're going to have 3.0, which is just 3. So 9t plus 3 would be my final answer for that one. Now, for this one with the fraction, the 1/2 multiplied by 8 minus 6j, this is something called a unit fraction. So whenever you have the numerator of a fraction be 1, that is considered a unit fraction. And what's really nice is that all it means is you're dividing by that denominator. So multiplying by 1/2, that's the same as dividing by 2. If this was 1/3, that would be the same thing as dividing by 3. If it was 1/10, that would be the same thing as dividing by 10. So don't let fractions deter you, especially when they're these unit fractions. They turn out to be really nice. So in this case, 1/2 of 8, the same idea, the thinking that we can use is that it's just 8 divided by 2. So this is going to be 4. Bring down your subtraction sign. 1/2 of 6j, or 6 divided by 3, is going to be 3. So you're going to have 4 minus 3j. And then that's it for that answer. And if you did have to rewrite this so that it was more in that standard form, you would write negative 3j plus 4, in case your teachers are a little bit more picky on, again, that variable term being first. Those two are exactly the same thing. So 4 minus 3j, or negative 3j plus 4, same thing, just wrote a little bit differently. One in its proper form. All right, so number 10 is the first one that we've seen where we are actually multiplying to several terms that are inside the parentheses. In this case, we have 3. Most of them have only had 2 terms inside. It's the same idea even when you have more than 2 terms. We're going to do 8 times p, 8 times 7, and 8 times 2q. So whatever's in the inside of those parentheses, however many terms, whatever's on the outside, you multiplied everything that's on the inside of those parentheses. So 8 times p is going to be 8p. 8 times 7, that's going to be 56. 8 times 2q will be 16q. And you are welcome to leave your answer just like this. If we needed to rewrite it in standard form, essentially we would just put those variables alphabetically, and then the 56 would be on the end. All right, moving on to the next one. So number 11. Again, we have some decimals going on here, but same idea as what we saw in number 8. You can just think of this as 32 times 4. So that's going to be our first step, right? 4 times that's 3 2/10. But think of it as 32 times 4. We can multiply that out. You got 128. However, we're going to add our 1 decimal place back in. So this is going to be 12 8/10 d. And then 4 times 10, that's going to be 40. And then that is as far as we can go on that question. All right, bottom left. So with this one, we're going to do 6 times 4c and then 6 times 2. Be careful not to over distribute because that 10 is on the outside of the parentheses. So the 6 does not get multiplied to 10. That's just going to be hanging out on the end until we can combine it with possibly a like term, or it just hangs out there if there's nothing it can combine with. So 6 times 4c is going to be 24c. We have our subtraction sign. 6 times 2 is going to be 12. And then we have the plus 10 again, like we said, it's just kind of hanging out there because it did not get the 6 distributed to it because it's not inside the parentheses. We can combine like terms on this one. So if I rewrite this as plus negative 12, it makes it a little bit clearer to see that this negative 12 and 10, those are our constant terms. They can be combined together to make a negative 2. So 24c, and again, instead of writing plus negative 2, we're just going to write it as minus 2. Okay, so number 13, same idea. We're going to take whatever is on the outside of our parentheses here. We're going to multiply to everything on the inside of the parentheses. So the 5b not being multiplied to. 6 times 3b is going to be 18b, plus 6 times 7, which is 42, plus we have the 5b that's just hanging out there. Combining our like terms, which in this case we have this 18b and then we have a 5b. So 18 plus 5 is going to be 23. So we'll have 23. So we're going to have 23b plus 42. Okay, so now on this last one, so for number 14, for this question, I've seen a few students who have tried to combine the 3x and the 2. Those, again, are not like terms. Or there's cases where they don't have the x next to it, right? So it would just be like 3 plus 2 if I were to just cross it out for a second. And a lot of students want to try to add that first. But if you go back, again, remember order of operations tells us that you're going to multiply, which is indicating you need to use the distributive property first. So we're going to end up doing the 2 times the 4x and the 2 times the 7. So just be careful when you have that term that's out front that's being added to, again, something that looks like this, not follow those order operations, right? So we got to do that multiplication first. So this 3x just hangs out front, plus we got 2 times 4x, which will be 8x, plus the 2 times 7, which will be 14. And now we can go through and combine like terms. So the 3x and the 8x, that's going to make 11x's total. And then we just have that plus 14 hanging out there on the end. All right, so the last piece in this video that is actually going to be touched on in a later lesson video when we talk about factoring, and it will be a whole video on that. I do want to touch a little bit on factoring expression in this video because it is a part of the distributive property, and essentially expressions can be factored to remove the common factor. And this is something that's going to help out a lot when you get to Algebra 1 and beyond, because you're going to be asked to factor polynomials, and this is the start of it. So factoring is essentially how we undo the distributive property. That's one way that I tell my students to think about it. You're undoing the distributive property. Essentially, you're unsimplifying that expression. So to expand or factor, because sometimes they say to expand, you can also see the directions down here say it a little bit differently. Rewrite each expression as a product of 2 factors. They all mean the same thing. Factor, expand, you're undoing the distributive property. So we got 4x plus 16 in this first example up here. So the first thing is you're going to identify the greatest common factor of the terms. Essentially, find the largest number that they can both be divided by. We have 2 terms. What's the largest number that can go into each of them? So then you're going to write the GCF on the outside of the set of parentheses. So I know that for 4x and 16, the GCF of those is 4, right? That's the biggest number that they can both be divided by. So now I'm going to have something left inside the parentheses. So to figure out what's left inside of it, we know there's going to be a plus sign because there was a plus sign that we ended with. 4 times what would give us 4x? That would have to be 1x or just x, right? So if I were to go back and redistribute this, 4 times x does give me 4x. Again, we already have the plus sign taken care of. And now we just have to say, okay, well, 4 times what is going to give me that 16? That's going to be a 4. And then that's it. That's your answer. And I know it looks weird because before we were like, oh, yeah, you got to simplify, get rid of those parentheses. Now, again, we're undoing it. So when you're asked to factor, you're basically unsimplifying that expression. So we're going to try it with these next 3, and then that's going to be it for this video. And if you still need help with factoring, make sure you check out the video that'll be posted later on that has to do with the entire video being about just factoring expressions. So for these last 3, we got 6a plus 2. Again, what is the GCF of 6 and 2? Hopefully we know that is 2. That is the biggest number that both 6 and 2 can be divided by. So 2 is going to be on the outside of my parentheses. Essentially, now we ask ourselves, 2 times what would give me 6a? That's going to be 3a. Bring down your plus sign. 2 times what would give me the 2? That's going to be a 1. And then there's my answer, right? If I were to remultiply this out, 2 times 3a would be 6a. Again, I got my plus sign. 2 times 1 gives me the 2. So now we're going to do the same idea with the 24x minus 9. What is the GCF of 24 and 9? The GCF, the biggest number that those can both be divided by, is 3. So now we're going to have 8x left because 3 times 8x would be the 24x. We have a subtraction sign in between. 3 times what is 9? That's a 3. Now, one way you can check too to make sure that you did actually find the greatest common factor is whatever's left inside the parentheses should not have any common factor other than 1. So that's a good way to double check too. So if you just, factored something out and you were still left with like 2 even numbers on the inside of the parentheses, or again, maybe you have 2 that are multiples of 5 that are left on the inside of the parentheses, that means you didn't factor out the GCF. You just factored out a common factor, but not the GCF, so you'd have to redo it. So last one on this one, the 10x plus 35. Again, looking for the GCF between the 10 and the 35. That is going to be 5. So 5 times what is the 10x? That'd be 2x. Bring down your plus sign. 5 times what is 35? That's going to be 7. And like I said, we will have a video later on that will go into more detail on factoring, but hopefully that gets you started with it. Hopefully this was also helpful with distributive property. Make sure you check out that last video where we will use the distributive property with a lot more negatives. Thanks for watching.